Okay, lesson 2 is going to be about exponential equations. Okay? Well, the first thing I want to do is I want to just do a little couple mental math things. Okay? So, here's my question. 3 to the power of what equals 27? Think about what number goes in there. How many times do we have to times 3 by to get to 27? Okay? And knowing these in your head and kind of working them through will make this a lot easier. That being said, you don't have to. Okay? If you're absolutely stuck, we can use a calculator. So if you think about this, 3 times 3 equals 9. 9 times 3 equals 27. So how many 3's do I have? I have 1, 2, 3. So 3 to the power of 3 equals 27. Okay, how about we do 5 to the power of what? Equals 125. Okay, I'm going to give you about 10 seconds each time. So that one's pretty simple. It's 3. So let's do a different one. 4 to the power of what equals 256. And sometimes you can have an idea about it and just use your calculator to check it. Okay, so I'll give you a little bit of time. And if you have an idea, let's go like, okay, how about 4 to the power of 5? Well, that's too big, right? 4 to the power of 4, 256. Okay? Now let's do like, what's 2 to the power of what equals 64? And that is 2 to the power of 6. So the main thing here is I want you to see how I can turn this number, like that number, into a power. Okay? Knowing your multiplication tables and kind of getting to know your bases and stuff like that will help you out. Okay? So let's start by doing our exponential equations. Now let's start with an easy one to kind of demonstrate what we're going to do. So I'm going to go 4 to the power of 2x equals 4 to the power of 8. Okay? So 4 to the power of 2x equals 4 to the power of 8. First thing you're telling me is, why is the variable up as the exponent? That makes no sense at all, right? So it's up there. Don't worry about it. So the big thing here is you have to get your bases the same. Once the bases are the same, you can just drop the bases. Because 4 equals 4, so that all equals the same. And then you're just left with 2x equals 8. Okay? And now here, we're solving the equation. So when you get down to here, I always say, there's kind of two ways to look at this. I always say you move it over, and it does the opposite. Right now it's 2 times x. So when it comes over, it's going to be 8. Instead of it being a multiply on the side, when it comes over, it's going to become a divide. 8 divided by 2. So x equals 4. You could always look at it like this too. I divide this side by 2. I divide this side by 2. These 2 cancels. This equals 4. So the big thing here are both the bases are the same. Okay, so let's do another one. So if I went 2 to the 4x plus 1 equals 2 to the power of 9. I'll try to slow down a little bit. I realize I go a little fast. But you can always hit pause as we go through. So here we go here. The main thing to look at is, are my bases the same? Well, yes, they are in this case. So my base is the same, I drop the bases, and then I can just work with the equations up top. Now this one has a little more to it. I need to move this over. So I got 4x equals 9 minus 1. It's a plus on that side, turns into a minus, or you can think about it as a minus 1 from this side, but the minus 1 from that side. So 4x equals 8. And then I divide this by 4, this by 4, x equals 2. We'll do one more like this, and then I'll go a little bit harder. Let's switch to a different color so we know we're on a different question. Let's go 16 to the power of 8x plus 2 equals 16 to the power of 2x plus 14. Okay. So we're here now. Big thing, base is the same? Yes. So let's drop them. Get rid of them. And we're left with 8x plus 2 equals 2x plus 14. Now we need to rearrange. I'm going to bring this 2 over here. I'm going to bring this that 2x over there, this 2 over here. So 2x, it was a plus 2 on this side, so it becomes a minus 2. And this was a plus 2 on this side, so it becomes a minus 2, which gives me 6x equals 12. Divided by 6, divided by 6. Now I could go back here and plug that 2 back into the equation, into the top part. So this is a check. 8x plus 2 equals 2x plus 14. Now we can plug that 2 in to each side. That equals 16 plus 2, which equals 18. That equals 4 plus 14, which equals 18. So our big check mark here for both sides equal each other. So hopefully the big thing here that you should take away from is if the bases are the same, we can drop the bases, and then we just work with the exponents in solving a simple equation. Okay? So let's change it up for you. Now, instead of having the bases the same right away, let's change it up and make the bases a little bit different. So let's go with 3 to the power of x equals 27. Okay? So right now, you'll tell me the bases are not the same. Right? So the bases aren't the same, so I need to do something. Well, I have a base of 3 over here. Could I make 27 into base of 3 to the power or something? So 3 to the power of what equals 27? Now luckily we already did this, so 3 to the power of 3 equals 27. So I can rewrite 27 as 3 to the power of 3. Those are both the same number. There's nothing different about them. Right? I just rearranged 27 to look a little different. 3 to the power of 3 equals 27. I haven't changed a thing. Now here we go again. Our bases are the same, so we can drop the bases. And then we're just left with x equals 3. Okay. So let's do another one here. And let's change it a little bit. So let's go with 81 equals 3 to the power of 2x plus 8. Okay. So here our base is the same right now. No. So we need to make the bases the same. Now we know the base is going to be 3 because this one's already 3. Okay. So we're trying to figure out what number goes up there. This is where you have to either practice knowing your cubes and so on, or you can just figure it out, right? And we can just honestly go 3 by 3 equals 9. So that's 2. Times by 3 again, that's 3, which is 27. Times this by 3 again is 81. So that was our 4th time we times it by 3. Right? So 1, 2, 3, 4. So that means our number here is going to be 4. Okay? Oops. Number here is 4. Now we have the bases the same, so we can drop our bases, and we can just work with the exponents all by themselves. Now, I have x's over there, so I'm going to move this over. So I have 4 minus 8 equals 2x. Negative 4 equals 2x. Then I need x all by itself, so I'm going to divide this side by 2, this side by 2. These guys cancel out. And this is negative 2. So the big thing here, we make the bases the same. Then we get rid of our bases since they're the same. We can drop the bases. Wish I had music that would drop the bass as I said that. So let's do another one here. 5 to the power of 10 plus 2x equals 125. Okay. I want you to pause it and try to work through that for me. I'm going to fly through the solution once I get it. So pause it right now. I know you've already paused it. You did the first time. So then try to work that out. So here's the solution. I'm going to give you the solution right now. So we know we need this base is the same. Now the base here is 5, so that's as low as it can go. So it's going to be the one we're going to match to. Now we had to figure out what 5 to the power of something was. Now 5 to the power of 3. Okay. Now we can drop our bases. And we'll end with 10 plus 2x equals 3. So we're going to move that over. So 2x equals 3 minus 10. 2x equals negative 7. And we divide by 2, divide by 2. X equals negative 7 over 2. Okay. I feel like we should do another one. Nice thing is you can just pause it and it's going to be a quick answer once you get it going. So let's go 2 to the power of 3x plus 4. He's probably going to end up as fractions, by the way, equals 64. So I'm just making them up off the top of my head, and there's nothing wrong with fractions. So pause it up, and once you're done, come back, and I'm going to give you the solution. In 3, 2, and 1, away we go. So 3x plus 4 is here. It's the worst 3 ever. That's horrible, even worse. Okay, 2 to the power of what equals 64? 2 to the power of 6 equals 64. Remember, they're the same number. Now we can drop our bases. So we end up with 3x plus 4 equals 6. Move that over. 3x equals 6 minus 4. So 3x equals 2. Divide by 3, divide by 3. X equals 2 over 3. And there's only one last thing I can do here. Well, it's 2. What if it looks like this? 4 to the power of 2x plus 4. Let's go 2x plus 3 equals 8. Oh, let's take away 8. Let's go 32. Okay? Now, logic would tell you, as we did before, we need a base 4, because that's all the ones previously were. Okay? But, if you go through 4, 4 to the power 1 equals 4, 4 to the power 2 equals 16, 4 to the power 3 equals 64. We can't. We need a 32 in here, but it's not working. So base 4 can't be what we need. We need something that goes into both of these. In this case, the base we're looking for is 2. Okay? The base we're looking for is 2. And that's what we need. I'm going to change this question just a little bit. I'm going to take away this part, the start. Okay? So now, we need to find a base they both go to. Now in this case it's 2. So this one here, 4, we could write as 2 to the power 2. But we still have this to be up here. So it's already up there. So it's 2x is up there. Equals 2 to the power 5 equals 32. Those two are the same number. Okay? 2 to the power 5 equals 32. Now we have our same bases again. And since we have the same bases, we can drop them. Which leaves us with 2 to the power 2x. 2 times 2x equals 5. We multiply in here, which would give us 4x equals 5. And then we're back to the exact same spot we were before. Divide by 4, divide by 4. X equals 5 over 4. So to review here, we need common bases. Right? Usually, or sometimes, like these questions, we could make 125 into a 5 base. 5 base for the power 3. We could change 64 into a power 2. Okay, we could change those things up. But sometimes you can't. In this one, we couldn't. They're different. We couldn't get 32 from using 4 to the power something. Try that first. 4 to the power, 4 to the power. And if you realize you can't get the 32, you need to try something different. Okay? So let's do another one here. Let's use 81 3x. Let's erase that. Equals 27. I want to put something up there. Let's not put anything up there yet. Oh yes, let's. X plus 1. Make it nice and easy. So now, we know that we can't get the 27. 27 to the power 1 is 27. once we go 27 squared, that's going to be 729. That's a big number. So we can't get to 81. So there's no 81. Okay? So we need to find a different base. We need to find a base that both of these work with. Okay? So we can start guessing different numbers and kind of work backwards with it. Now luckily I'm a math teacher and I made up this question. So I know the base we're looking for is x. I'm going to write these numbers up here already because they're up there. We need to fill in what's going to go in this spot here. Now we learned earlier 3 to the power of 3 equals that. And you can just break out your calculator and try different things. You go 3 to the power of 2. What's that equal? Okay. 3 to the power of 3. Okay, I got that. Now what's 3 to the power of 4? 81. So over here is going to be a 4. So I've rewritten this as a 3 to the power of 4, and I rewrote this as 3 to the power of 3. Okay? Now, since we have the same bases, we can drop the bases, which leaves us with 4 bracket 3x equals 3 bracket x plus 1. And now we distribute in. So 4 times 3x is 12x equals 3x plus 3. Then we need to rearrange. Can move that over. I'm going way too fast again. Maybe you guys have to play me back at half speed or 3/4 speed. So to review, we found our common base to be 3. Well, we put our numbers to the power out. Now, since the 3x is already up there, we have to multiply in. So after we dropped it by the bases, we have to multiply into our brackets, which gave us this here. Then we need to rearrange and get all the variables on one side, which we did here, which is going to equal 9x equals 3. Then we divide by 9 on both sides. So x is going to equal 3 over 9, or 1 over 3 if we reduce the fraction. All right. Last one to practice. So 8x plus 3 equals 16 2x plus 1. Okay. So if you want to use this one as your guide, you can take a shot at this one and pause it for me and go from there. One second, I'm just emailing someone. Okay, so I'm going to go through and give you your answer for this one. Now we need a similar base here, because 8 squared is going to be 64, so we can't get to 16. So my base is going to be 2. And I like to write up the numbers up here already, that are already there. I'm going to write my exponent that's already up there. Okay? So 2 to the power what equals 8? That's 2 to the power 3. And 2 to the power what equals 16? 2 to the power 4. So 2 to the power of 3 equals 8. 2 to the power of 4 equals 16. Now I have my common bases. I can drop them. And then I'm left with this. 3 bracket x plus 3 equals 4 bracket 2x plus 1. I'm going to multiply in. The students who I used to teach would know rainbowing. So equals 3x plus 9 equals 8x plus 4. Then I need to rearrange. So I'm going to bring the 3x over there. I'm going to bring this 4 over here. So it's going to be 9 minus 4 equals 8x minus 3x, which is going to equal 5 equals 5x. Divide by 5, divide by 5. X equals 1. And there's our answer for that one. Okay? So hopefully I'm in class tomorrow, but if I'm not, hopefully all this helps you out. Feel free to go back, pause it, and go forward, and things along those lines. Okay?